Microsoft camera front. Okay. So we continue again. All right. So in short, if you want to calculate probability of event A happen, then what is the formula you should use? The formula is using NA divided by NS. Okay. So this is the formula, very important formula to apply for this chapter. I stop for a while. Any question on this? Okay. Okay. So what is the meaning if the probability value is equal to 0? Okay, I move to the next slide. Okay, what is the meaning if probability A value is equal to 0? That means event A is not going to happen. Okay. If probability A is equal to 0, that means event A is not going to happen. Confirm, not going to happen. That means 0% event A is going to happen. Okay. What is the meaning if probability A is equal to 1? That means 100% event A is going to happen. Confirm, going to happen, very certain. Okay. If probability A is equal to 0.7, what is the meaning? How to interpret this? The meaning is 70% of chance event A is going to happen. Okay. All right. So in short, the probability of what event, the value must be between 0 to 1. Cannot be negative number, cannot more than 1. If your answer is negative or more than 1, something wrong with your answer. Okay. But probability value can be equal to 0, can be equal to 1. Okay. So this is the second concept that you need to know. This is the way you check your answer for probability. Okay. So far, so good. Okay, next concept. So we go for the basic concept first. We need to understand first all these concepts. Okay, before we try to solve the real problem. Okay, there is another rule that I like to introduce to you. That is complement rule. That is probability A plus probability non-A. This A bar means non-A. Okay, non-A, that means event X is not going to happen. Okay, probability A means event A is going to happen. So if probability A plus probability non-A always equal to 1. Okay, probability A plus probability non-A always equal to 1. So we can use the Venn diagram to represent the relationship between event A, event of non-A, and also the overall set semester. Okay, so assume that this whole beige color area is plus the blue area, the whole thing, all the elements. All of the 1020 students who enroll in this semester, how many of them? 103 right? So in this case here, the total element of set semester, okay, the beige area plus the blue area altogether will be 103. That is the meaning for our study this morning. We want to know probability of FCE10020 students who have a laptop, okay, in this semester. Then how about set A here? This A area means the students who have laptop. Okay, so how many of them? 90. Okay, so we put here 90. Right? Then how about outside this area, outside the circle here? There'll be those students who 103. So you'll get the non-A area. So the non-A area is 103 minus 90. So you'll get the non-A area, which is those beige color. Okay. This whole overall diagram is called as the Venn diagram. Represent the relation A, non-A, and also the overall set semester. Okay. Next. Okay. So let us try to apply the formula that we learned this morning. Okay. So what is the question? Example 1. Okay. So we want to do experiment. Experiment is if you throw a fair die. What is the meaning of fair die? This is the die, right? But this is only a toy die. This is not a fair die, right? So this die consists of how many faces? How many faces? So score 1 here, right? So 2, 3, 4, 5, 6. So this die has 6 faces. Okay? 6 faces. Right? So we need to understand first the characteristics of the object that we want to study, right? So we got 6 faces. So that means the NS for this question, for this experiment is 6 NS. So maybe I can put here. Just put here. So that means the total number of elements, or we call as the faces, for a dice is 6. All right. So if you want to calculate probability, okay, what is the probability? If you throw a dice, okay, the dice will show a face of 6, score 6. Throw, oh, mine is, okay, let's look at 6, okay, this dimension, this face, So how many faces got consists of score 6? Only one face, right? So the numerator for this question is 1 only, right? So NS is 6, we know, and then the number of elements that consists of score 6, only 1. So we already know the NS, the NA value. Okay, now we use the formula that we learned this morning to calculate the PA. Okay, so the PA is equal to NA divided by NS, so you get 1/6. Okay, so you may leave the answer in fraction number. This is the simplest fraction number, so you can leave the answer until here enough. Because if you leave the answer in decimal number, then this will create the rounding error. Right? This answer is equal to 0.1666, right? Continuous. If you really want, you can round the answer to 0.1667. Okay, round to 4 decimal places, but I encourage to just leave the answer in fraction number, okay, in order to avoid rounding error. First example, okay, okay, then we'll move on to B, B is if you throw a dice again, one more time, throw a die. What is the probability? You'll get even number. So we need to understand first what is the meaning of even number, Even number means all the numbers which can be completely divided by 2. Okay? Even number means the number that can be completely divided by 2 means even number. Okay, so a dice, okay, for a dice, how many dimensions consist of even number? We have score 2, even number, score 4, and score 6. So there are 3 faces consist of even number. Okay, so for this question, a dice consists of 3 faces, okay, that have even number. Here I put n. This is even number. Okay. Okay, this question is involved a dice, right? A dice consists of 6 dimensions. So that means for this question, the NS is 6, always equal to 6. Okay. So since we know the NA and also the NS, now we have to substitute these 2 numbers into the formula that we learned this morning. So 3 divided by 6, you'll get 1/2. So if the fraction number can be simplified, please simplify. Or you can leave the answer into decimal number because it's a finite decimal number. You'll get 0.5, also okay, acceptable. But please remember to simplify this fraction number. Otherwise, half mark will be 0.25 marks will be deducted. Okay, so please try to simplify this fraction number. You can use calculator to help you. Okay, C is probability that if you throw a dice again, probability that the number, okay, will show a score less than 5. Less than 5. So for this question, it's not include 5. Less than 5 means it's not include 5. Okay. So for a dice, how many dimensions consist of score less than 5? There will be 1, 2, 3, 4. 4 dimensions on it. So in this case, I can write number of faces or number of dimensions that have score less than 5 will be 1, 2, 3, 4, right? So 4. Okay. So I can put score less than 5. That will be answer is equal to 4. Right? And then for this question, the experiment involved is a die. In total, a dice consists of 6 dimensions. So NS is equal to 6. Okay. So once you know the NA and NS value, substitute these 2 numbers into the formula. Okay. So for those who come late, okay, probability A is equal to NA divided by NS. Okay. This is the major formula that you need to know. Okay, so far we only apply this formula. Okay, yeah? Okay, some more example. Okay, we have D. If you throw a dice, what is the probability you'll get score 2 and 4? That's the meaning. That means you'll have 2 scores. Is that possible? If you throw a dice, you'll have 2 different scores? No, right? Not possible. You can only have 1 score. Okay? You cannot have 2 scores at the same time. Because this experiment only 1 time, right? You only throw the dice 1 time, and then you're asked to find out what is the probability you'll get score 2 and 4 at the same time. Is that possible? No, right? Not possible. So answer is 0. Okay. Answer is equal to 0. Because it's not possible, the dice will show 2 different scores at the same time. Okay. So far, okay? Right. Okay. Next example would be, what is the probability? The dice will show score 2 or 4. Okay. 2 or 4. Either 2 or 4. All right. So how to solve the problem? Okay, we have to find out first. What is the probability to get score 2, right? Score 2 is 1/6. Why 1? Because a dice has only 1 dimension, consists of score 2, right? That's why it's 1. 6 is because the object of the experiment is a die. A die consists of 6 dimensions. So you have to put an S here. Okay. Or in statistics, or means plus. Okay, means plus, plus. So we use plus. Plus what? Plus the probability. We'll get score 4. Answer is also 1/6. Okay. 1/6. This is for probability to get score 4. This is the probability to get score 2. So now we have to sum up these 2 fraction numbers. Sum up. So you get 2/6. You can use calculator to help you. Let's simplify. I get 1/3. So bear in mind, your answer for probability value must be between 0 to 1. Cannot greater than 1. Cannot be negative number. So simple, we already done simple experiment for a dice. Okay, okay, next. Okay, this example is a more, because it's a real life example. All right. So now we have 100 people as involved in the survey for identifying their preference bank. Okay. Okay, so from the statistics, we know that 20 customers prefer to choose Bonza Bank, and then 26 of them prefer Combank, 34 of them prefers Netibank, and the remaining 20 prefer Milkbank. Okay, the total number of participants who involved in the survey consists of 100. So in this case, NS is equal to 100. Right? For this question, NS is equal to 100. Number of participants who involved in the survey altogether 100. So it's NS. All right. Okay. Next, the question is asking, what is the probability if you choose one customer among these 100? If you choose one randomly, okay. What is the probability that this customer prefer Combank? Okay, prefer Combank. So that means this question is asking for probability Com. Okay, probability Com. So what is the formula we can apply? We can apply the formula that we learned this morning. So that is NCOM. So NCOM is referred to number of customers who overall number of customers who prefer Combank. How many? 26 of them. So we put as numerator. Denominator is total number of participants who involved in the survey, 100 of them. So simplify, I'll get 0.26. Or you may leave the answer in fraction number, either one. So far, okay? We use the same formula, NA divided by NS. Okay, next. Okay. So in the real world, okay, there will be more than one event. In the real world, there will be more than one event. All right? So if involve 2 events, okay? If involve 2 events, let's say A and B, then we can also calculate the probability of A union B. That means involve A and B. So what is the formula we can use? We can use the union rule to help us. Okay, if the real world, if the experiment involves 2 events, then we can use some of the rules in order to help us to solve the problem that involve 2 events. Okay, let's say we have probability A A union B. What is the meaning of union? Want to include either A or B or both of them. That's the meaning. Okay. Union means property of A, B, or both. Okay. So we use union. Huh? So what is the formula to calculate the property A union B? Formula is using property A plus property B and then minus the property A intercept B. So you may ask, what is the reason we want to minus this part? Is because of this area. Intercept point is this area, this part, because it's an intercept. So we don't want to have double count. Okay, we don't want to double count. So we need to minus this area one time, because this area is the A intercept area. Okay, if we include these two areas two times, this area two times, that means it's double count. So we need to count only one time for this area only, this part, the intersection area. So the formula to calculate A union B is equal to A plus B and then minus probability A intercept B. Okay, so this is the union rule. Okay, so let's try the one example. Okay, before that, okay, I'd like to also introduce to you what is the meaning of mutually exclusive. Okay, two events are mutually exclusive if two events never happen at the same time, never overlap at the same time. Then we can conclude A and B are mutually exclusive. A and B are mutually exclusive when both events never happen at the same time, never overlap in any area. Okay, so if you draw the Venn diagram, you may find that A and B never meet each other. Okay, so that means probability A intercept B is equal to 0. Okay, A intercept B is equal to 0. That is the very important characteristics for mutually exclusive events. Okay, because A intercept B never intercept, let's say A and B never intercept for mutually exclusive. Then if you want to calculate probability A union B, then what is the formula? Formula is still using this. Okay, for mutually exclusive, we're still using the same formula that we used to apply for the union rule. We use this formula. All right, but you may find that interestingly, for this part, probability A intercept B is equal to 0 for the mutually exclusive event. Okay. So the answer for A union B that involve mutually exclusive event will be probability A plus probability B only. But anyway, the formula is still using this to calculate the A union B, for mutually exclusive. Okay, next. Okay, let's try to identify all these cases, whether the two events are mutually exclusive or not mutually exclusive. Okay, question 1. Swimming and sitting and exam. Swimming and sitting, I should put an online exam. Let's say an online exam. That would be better. All right, swimming. Do you think that okay? You can swim and also doing online exam at the same time? Can these two activities be conducted by the same person at the same time? Cannot, Or I use online, then they cannot be argued anymore, right? So if there's a case, swimming event and sitting and online exam are two mutually exclusive events, because these two events cannot happen at the same time. Okay. Okay. Number 2, rolling score 5 and rolling score 3. We die. Only one die. So can you draw? Can you get a score of 3 and also score of 5 at the same time if you throw only one die? No, not possible to get two different scores at the same time. Cannot. So for this question, these two events are mutually exclusive also. Okay. Next question. Okay, living in Kota Semarang and working in Kuching City. Kota Semarang is one of the areas. Okay, in somewhere near Kuching. All right, it's somewhere near Kuching City as well. Okay, quite near. It's a driving distance. Okay, and working in Kuching. So can these two events happen at the same time? If you live in Kota Semarang and also working in Kuching, can these two happen at the same time? Yes, right? Because we have route to connect between Kota Semarang and Kuching and the suburb is very near. Okay, so these two are non-mutually exclusive. Okay, next question. Being under 21, that means at the age below than 21, and become Malaysian Prime Minister, possible? If you study the law, in fact cannot. Okay, to be a Prime Minister in Malaysia must be more than 21 years old. So the event of the age less than 21 and the event of becoming Malaysian Prime Minister, these two are mutually exclusive events. Okay, 5. Being a parliamentarian and a farmer, is that possible to happen? Farmer can be a farmer and parliamentarian. Huh?
No.
Okay. So these two can happen at the same time. Right? Just like we have this parliament, but we have this YB also to be parliamentarian and also a lawyer to have side income also, right? So these two events can be happen at the same time. Number 6, drawing a red card and ask for a pack of cards. Are these two events can happen at the same time or not? Are they able to happen? Right? Draw a red card. And the card is red color, right? With an X is possible. So this event can happen at the same time. Yeah. Okay. Next. Okay. What's the meaning of independent event? Okay. Event A and event B are independent events. Right? If occurrence of event A is not going to affect probability of event B happens and vice versa. That means chance of event A happen is not going to affect chance of vice versa. Then we can compare A and B.
Sorry, your voice.
Go to property A multiply property B. This formula you need to remember. So this formula is applicable only for independent events. Okay. And one more thing that I'd like to share with you also. Property A is given that B or this symbol means given or if. This symbol, the slash symbol means if or given. So given that B already happened, therefore it's the answer. Answer is still equal to probability N. Why? Because A is not affected by B. Similarly, also, if you're asked to calculate probability B, given that A already happened, if A and B are independent events, then the answer is equal to probability B. Okay, so you may ask now, any example in the real life? In the real life, we have these independent events. Any example? There are a few examples. Okay, one of the example is throwing 2 coins. Throwing 2 coins. Let me see whether I have coins. I have 2 coins, but small coins. 5 cents and 10 cents. All right. These 2 coins are 2 separate entities or separate objects. Okay. So let's say I throw this 10 cents as the first event. I get the result, right? And then I throw another coin, get the second result. Right? So the first coin and second coin result are not going to affect each other. Okay. So these 2 activities are considered as independent events. Throwing 1 coin, first activity. Throwing second coin activity. These 2 coins results are not affected each other. Okay. So that means these 2 events are independent events. Okay. Independent events. So that means probability A union B is equal to probability A multiply probability B. Okay, so let's try to start to answer this question. Okay, so this question is if you throw 2 coins, okay, how many outcomes are possible? How many possible outcomes? Okay, so this question is asking to list down how many possible outcomes. So at first we need to understand first the characteristics of a coin. So a coin consists of 2 faces only, right? It can be a head, and this one is a tail. Head and tail, only two faces. So that means for this question, the NS is okay. For one event is 2, right? Okay, 2 faces. Okay, you're asked to identify what are the possible outcomes. So the possible outcome can be both of the coins will get the result of head. Okay, if you throw these 2 coins, both coins will show the result of head. So I use head to represent head. Head. First coin is head, second coin is head. Or it can be the first coin is head, second coin is tail, right? Or it can be the first coin is tail, second coin is head. Okay, and lastly is both coins will show tail. So there will be 4 possible outcomes. In this case, the NS is 4. Because it got 2 events now. So the overall, okay, the overall consists of 4 possible outcomes. Okay. So for this question, the NS is 4. There are 4 possible outcomes. Because we got 2 activities, different activities. Okay, B, how many of these have 1 head and 1 tail? Okay, so this question is asking if you throw 2 coins, okay, so how many outcomes will show 1 head and 1 tail? So it can be this outcome. This is the possible outcome. So I try to highlight. Okay, to get 1 head and 1 tail, it can be this outcome, right? It can be this one. I move to the back, okay. Okay, and another outcome is this one, right? Another outcome, possible outcome to show one head and 1 tail will be this. Okay. So there'll be 2 possible outcomes for this question. There'll be 2 possible outcomes to show 1 head and 1 tail. Okay, so this is asking, what is the probability of getting 1 head and 1 tail? Probability of getting 1 head and 1 tail. So that means that if I use an equation, that means it's the ask to calculate the probability of 1 head and 1 tail, right? So what is the formula that we can use? Formula, even though in the 2 events, right? So the formula is equal to number of outcomes that consists of 1 head and 1 tail. That's the numerator. And then the denominator is number of sample space.
Sorry, we can't hear you.
So the numerator is equal to 2. So substitute 2 from here. For your part B answer, put here 2. Your NX is from your A answer, 4. Put here. Simplify your get 0.5. Okay. Okay, D. What is the probability of getting 2 heads? Confirm, 2 coins will show head. That is the meaning. So if you want to use the same formula, you can apply this formula. So this question is asking for probability of 2 heads. Okay, so at first we need to identify how many outcomes that will have 2 heads. This one only, right? So I use other color. I use this one. This is the possible outcome, right? Only one outcome, the one possible outcome got head, right? So answer is 1 here. How about the denominator? Denominator is 4, because this question involves 2 events, there will be 2 coins. So answer is 1/4. If you simplify, I get 0.25. So far, okay? All right. There is another way to solve this type of question. I will share with you another method to solve the problem. Okay. Okay, for A, let's say if you ask to calculate probability to have 1 head and 1 tail, another way to solve the answer is, okay, you have to identify the possible outcome. It can be either the first coin will show head and second coin will show tail. Okay, or another possibility is the first coin will show tail and the second coin will show a head. Okay, so there will be 2 possible outcomes here. This is another way to solve the problem for this type of question. Okay, either this or this will happen. Okay, this combination. Okay, so let's try to solve this part. What is the probability? You'll get the first coin is head. Answer is 1/2. Okay, what is the probability to get the second coin is equal to tail? Answer is 1/2. Even A multiplied with even B. Okay, so I put here 1/2. Okay, then we'll move on to the second outcome here. What is the probability to get the first coin is equal to tail, answer is 1 over 2. Second coin is equal to 1 over, is head is also 1 over 2. Simplify, you'll get 1 over 4 for each outcome. Okay, then we sum up these two outcomes, you'll get 1 over 2. So this is another way to solve the problem for the question that involves 2 coins. Okay, next example, 2 heads, very confirm. Okay, this one is very certain. Both outcomes are head. So it's only that means only one possible outcome. Sequence is no longer important because both coins will show the same result. So only one possible outcome, head. Okay. So this we not cover, we call it double count. So the answer cannot be H1, H2 plus probability, H2 plus H1. No need. Double count, that will be double count. If the 2 coins will show the same outcome, we only count 1 time. Okay? Count 1 time only. So there is only one possible outcome for this question. So simplify, I get 1 over 4. Okay. Yes.
The online chat is not hearing you.
They cannot hear me.
Yeah.
Okay, let us try again. Up now. Oh, can you hear me now? The online students. Can the online students hear me?
Yes.
Hello.
Hello.
Cannot. I think I have to on this one then. Hold on. Finally. How about now? Can you hear me? But the problem
Sure.
is.
Sir, we didn't understand the independent variable, the independent one.
Okay, this one I mute again. Hello, can you hear me? Can the online students hear me? Hello. Okay, let us try to check again.
Yes.
Can you hear me now? Alice,
Yes.
Jasmine. Okay, I try again one more time. Are you able to hear me?
Yes.
Can. Okay, good. I think I have to hold this mic. Can you hear me now? Yeah. Okay. Okay, so I already done the explanation for the events that involve 2 coins, right? So now I'd like to move on to the next experiment. Okay, this experiment involves 2 this is 2 dice. Okay, 2 dice now. So this question is, if you throw 2 dice, or one throw of 2 dice, right? What is the okay, you have to list down the sample space. Okay, for this question, now you're asked to throw 2 dice. So that means the 2 experiments, the events involved will be throwing 2 dice. Okay, let me see. I have any dice. Yes, I have another dice, right? So now the question is involve throwing 2 dice. 2 dice at the same time. So throwing the red dice and throwing the white dice are considered as 2 events. And then these 2 events are independent events. Independent events. Why? Because throwing the red dice result will not affect the white dice result and vice versa. Okay, the white dice result will not affect the red dice result, and the red dice will not affect the white dice result. As a result, these 2 events are considered as independent events. Okay, independent events. If independent events, we have to go back to the formula that we learned just now. Right? So for independent events question, probability A intersect B, if these 2 are independent events, then the answer is probability A multiplied probability B. So let's go back again to the example 5A. Okay. For question A is you are asked to list down the sample space. Sample space means the NS. For this question, you need to list down the sample space. That means the possible outcomes if throwing 2 dice at the same time. Okay. So what are the possible outcomes? In total, there will be 36 possible outcomes if you throw 2 dice. So what are the possible outcomes? It can be the first dice will show 1, score 1, and second dice also show score 1. Or it can be first dice will show score 1, second dice will show, this is a dice that also score 2. Or the last combination can be both of the dice will show score 6. So in short, if the question involves 2 dice, there will be 36 possible outcomes. So if the question involves 2 dice, it's better for you to list down all the possible outcomes, 36 of them. List down first. Very important because we need this information later on to solve the problem. Okay. All right. So part B, find the probability of getting a score of 5. Okay. If you throw 2 dice, what is the probability you'll get a total score of 5? What's the meaning is? If you sum up the score from the online student, if you sum up the score from red dice and the score from white dice, you will get 5. That's the meaning. Okay? Sum up the dice from white dice and red dice will get a total score of 5. So, okay, how is the probability? So in order to solve the problem, we need to identify the number of elements that consists of total score of 5. Okay? The total possible outcome, the number of possible outcomes that have score of 5. So let's go back to the 36 outcome here. Check which combination of outcome have total score of 5. It can be 1 plus 4. Right? That means the red dice will show score 1 and the white dice will show score 4. 1 plus 4 is equal to 5. Okay. Any other combination, yes, it can be 2 plus 3. Okay, or it can be 3 plus 2, also 5. Or it can be 4 plus 1. So that means there will be 4 possible outcomes in order to get total score of 5 from 2 dice. That's the meaning. So that means for this question, for B question, the numerator is 4. Denominator is because got 2 dice involved. So altogether 36 possible outcomes. Okay, so simplify, I get 4 divided by 36 is equal to 1 over 9. Okay, I stop for any question on this. Total score 5 is you have to sum up the red dice score and the white dice score. You get 5. That is the meaning. Okay. Okay. C. What is the probability of getting a score of more than 5? More than 5. So that means if you sum up the red dice score and also the white dice score, you'll get the total score more than 5. Cannot include 5, but should be more than 5. That's the meaning. So what are the possible outcomes then? It can be 1 plus 5, 1 plus 6, right? Or 2 plus 4, 2 plus 5, and until 6 plus 6. So these are the possible outcomes in order to get the result of total score more than 5. So how many possible outcomes? Okay, we count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Altogether 26. So we substitute 26 to the numerator value. Okay, and 36 is because this question involves 2 dice thrown. Okay, involves 2 dice. That's why it's 36 as the denominator. So simplify this fraction number, you get 13 over 18. Or you may round the answer to a decimal number. So far so good. Hopefully the online student can hear me now. Echo. So much echo.
Teacher. Teacher.
How about now, Brian? Still
Okay.
have echo?
Teacher. Try turning off the mic on your
Still echo?
Try turning off the mic on your computer. Now we
How about now?
yeah.
Now it's okay? I
Yeah,
think,
so-
yeah, sorry, because I think I have to switch on the mic for my laptop. How about now? James, okay, okay.
Good.
Yeah. Okay, now we go back again to the PowerPoint slide. Sorry, yeah. Okay. Next example, let's see what is the example now. Okay, this one, 5B. Bear in mind, we're still under the independent events question. Independent events means property A will not affect property B and vice versa. Two events will not affect the chance happen among each other. Okay, so let's try this question again. Okay, this is example 5B. So this question is, there are 5 blue balls and there are 6 blue balls and 5 red balls in the box. Okay, so in total there are 11 balls in the box. Without consider the color difference. 11 balls in total. So that means NS is equal to 11. NS, okay, 11. NS means 6 plus 5. And NB, I use B to represent blue. So NB is 6. And red, I use R. So that means NR is equal to 5. Okay. Maybe I can write it down first. Write down somewhere. So for this question, I can conclude that NB is equal to 6. Right? Hopefully you can hear me. Okay. I just do a draft first based on the question given. Right? And then NR, I use red R to represent red now. Okay. And as I can also conclude that the NS, that means the total number of balls inside the box without consider the color difference is 11. Okay. So I temporarily write down first. Okay, so now, okay, the next sentence is what? If 2 balls are randomly taken one by one with replacement, what's the meaning? That means, okay, inside this box, okay, there are 11 balls. We assume that got 11 balls. Okay, so now you have to randomly select, select one by one. Let's say, okay, the first ball I select, okay, it's red. Okay, one by one. That's the meaning. Okay, without replacement, that means after I select the first ball, I just put this one, this ball, outside the box. All right, before I select the second one. Okay, now I select another one. Oh, it's blue ball. Okay, the second ball is blue ball. So that is the meaning of the process of selection for this question. Okay, select 2 different balls with replacement. Oh, replacement. Replacement, that means we have to replace. Okay, that means after selecting the first ball, we jot down the color, then we put back the red ball inside the box before we select the second ball. That's the meaning of replace.
And now we cannot hear you. Teacher, we cannot hear you.
So there will be 2 possible outcomes in order to meet this criteria, choosing 1 blue ball and 1 red ball. It can be the first ball is blue, second ball is red. Okay, or it can be the first ball is red, second ball is blue. Okay, So we need to list down the two possible outcomes. Next step is to write down the value for each outcome. So let's try to solve the first outcome. What is the probability to have first ball is blue color? Answer is 6/11, right? Assume that there are 11 balls inside, right? Inside the box. We randomly choose one ball. Let's say, okay, what is the probability we choose color? That's the meaning. So answer is 6/11. Why 6? Because in total there are 6 blue balls inside the box, right? 11 is because no matter what color inside the box, there are 11 balls altogether. Okay. Then we return the blue ball, the first blue ball is okay, return inside the box again. All right. Then we select the second ball. What is the probability? The second ball is red color. That's the meaning. So answer is 5/11. Why 5/11? Because in this box, there are 5 red balls, right? 11 is because, don't forget, we return just now the first ball, right? We return, right? After we're selecting the ball, we return the first blue ball inside the box. Okay, before we select the second ball, which is red color. So answer is 5/11 for the second red ball. Okay. So this is the first outcome. Okay, plus the second possible outcome will be the first ball is red, second ball is blue. Okay, so what is the probability if we choose one ball from this box? What is the probability we get the first ball is red color? Answer is 5/11. Okay, 5/11 because there are 5 red balls inside the box. Right? So we return the ball, the first ball we return. Okay, then we choose the second ball. What is the probability we get the second ball is blue color? Answer is 6/11. Okay, so remember we still use 11 as the denominator for the second, right? Because when we choose the first ball, right, we return the ball before we choose the second ball. That's why for the second event, the denominator is still 11. Okay, so let us try to simplify this expression. Okay, for the first outcome, simplify, you'll get this one will be 30/1 to 1. Okay, 6 multiplied 5, you'll get 30, right? 1 to 1 is can hear me, but now hence they had to control microphone and PowerPoint slide. Okay, okay. Next question. Next question is what is the probability of choosing at least one red ball? At least one red, Okay. So now we choose two balls. Okay, what is the probability to have one red ball? So at first we need to list down first the possible outcomes. It can be the first ball is blue, second ball is red. First ball is red, second ball is blue. Or it can be both of the balls are red color. So bear in mind, if both colors are the same, we just count one time only. If both of the balls have the same color, we just count one time. Okay. Some students may ask, should I plus P R2 multiply R1? No need. If the same balls have the same color, we just count one time. Okay. This is a tricky part. Okay. So once you identify the possible outcomes, the next step is to substitute the number into each outcome. Okay. So for this one, what is the probability to get the first ball is blue color? 6/11. Okay. Multiply with the second ball is equal to red color. Answer is 5/11. Okay. Plus the second possible outcome will be first ball is red color, 5/11. Multiply with the second ball is blue color, 6/11. Okay. And then the third outcome can be both balls are red color. So substitute 5/11. The outcome, simplify here again. What is the probability of choosing two red balls? Very certain. Both of the balls chosen will be red color. Very certain. Okay, confirm. So that means there will be R1 and R2. Only one possible outcome. Okay, R1 and R2. The first ball is red and second ball is also red. Okay, so answer is 25/1 to 1. Okay, last question. What is the probability of choosing both balls? Okay, with similar color, same color. That is the meaning. Also very certain. So there'll be two possible outcomes. It can be, the first outcome can be both balls are blue color, or the second outcome is both balls are red color. So we substitute 6/11 for the first outcome. Okay, and then for the second outcome will be first ball is red, second ball is red. Simplify, I'll get 61/121. So far, okay? So far, so good. So the tricky part is if both colors are the same, we just count one time only. Count the combination one time only. Okay. Okay. So just now in short, right, we already learned the independent events. Independent events means occurrence of one event is not going to affect the chance of another event happen. So if there's a case for independent events, probability A intersect B is equal to probability A multiplied probability B. Okay, the example will be throwing one dice and one coin, throwing two dice at the same time, throwing two coins, choosing two balls one by one with replacement. These are the examples of independent events. Okay. Okay, last one will be dependent events. This is more challenging now. Dependent events. So in the world, most of the events, okay, depend to each other. Are dependent to each other. So what's the meaning of dependent? That means that the chance of event A happen will affect the chance of event B and vice versa. And then we can conclude A and B are dependent events. Okay, let's say example of dependent event will be smoking habit and chance to get cancer. Can be considered as dependent events. Okay. Attending tuition and getting a pass in the exam can be also independent. Can be considered as dependent events. Okay. So what are the characteristics of dependent events? Okay, so for dependent events, you need to know some of the formula. Okay, so let's say this one. If you're asked to calculate probability A, given that B already happened, if A and B are dependent event, that means depend to each other. A and B are dependent to each other. Then if you are asked to calculate probability A given B, then the formula is equal to probability A intersect B divided by probability B. This formula you need to remember. Very important. It's only applicable when A and B are dependent. Okay. Similarly also, if you're asked to calculate probability B, given that A already happened, okay, this slash means given. Given that A already happened, then what's the formula? Formula will be probability B intersect A divided by probability A. So if A is at the back, that means A will be used as the denominator. Okay, like this. If B is at the back, that means B will be used as the denominator. Okay, so bear in mind, A intersect B is the same meaning as B intersect A, same meaning. Okay, so this part, A intersect B, is the same value of B. However, probability A given B is not always equal to probability B given A. Okay, not always the same. But A intersect B is equal to B intersect A, same meaning. Okay. Usually for the dependent events question, it's better for us to use either tree diagram or we can use the joint probability table to help us to solve the dependent events question. Okay, so I think I would like to show you now the joint probability table first. Okay, so I'll move on to this table. It's about the age and also the income of the respondents, which is example 9. So for the online students, you can refer to example 9. We have a table here. Okay, we have age. Okay, this table is showing the age and also the marital status. Okay, so the two variables are age of the participant and also the marital status, whether it's single or married. So these two variables can be considered as dependent event. All right, and now it's in the joint probability table form. So based on this table, we know that okay, how many of the participants are under 30? Altogether, 91 of them are under 30 years old. And how many of them are equal to 30 years old or above 30 years old? 49 of them. All right. How many of them are single? 105. And how many of them are married? 35. So in total, how many participants involved in this survey? 140. So this is your NS, okay? NS is 140 for this question, NS is 140. Okay, so now is you ask, the first question is, okay, if you choose one customer randomly from this 140, you choose one randomly, choose one randomly. What is the probability? Yeah, this customer is single and under the age of 30. Okay, single and under the age of 30. All right, so what is the meaning of this sentence then? Okay, we try to translate into a mathematical equation. All right, so this one means you're asked to calculate probability. The customer is single and under 30. Okay, so this is the meaning of the question, right? So we still can use the formula that we learned this morning, right? Remember the formula that we learned? Okay, so we need to identify first how many of these customers fulfill these characteristics: single and below than 30, right? Divided by the NS. So this is the formula that we should use, in order to answer this question, right? Using NA divided by NS. This one okay? Can you follow? Okay, so how many of the customers fulfill these characteristics? Single and below than 30 years old. This will be your numerator. How many? Single and under 30. So you have to identify the cell. Is this one, right? So 77 of them are below than 30 years old and single. So we substitute 77 to the numerator. How about the denominator? Denominator is the total number of customers who involved in the survey. Altogether, how many? 140. So substitute to here as a denominator. Simplify, you'll get 0.55. Okay? Can you follow? Okay, First question, okay, quite easy, Okay, next. So that means we're still using the formula that we learned this morning, in order to solve the problem, right? The first formula we learned. Okay, B. So this question is, if a customer is under 30, okay? If that means conditional, okay? Given that the customer is under 40, What is the probability? He or she is a single, is single, So this question, what is the meaning of this question? How to translate this sentence into a mathematical equation? What is the meaning? So this question means if under 30, so we have to put under 30 after the slash. You need to create a slash sign here and then put under 30. Given that we know that it's under 30. So we put at the back, under 30. What is the probability? The customer is single. So single we put in front. So the overall sentence is referred to this one. This is the meaning. Okay, this is the meaning. Here, all right? Okay, so how to simplify this? What is the meaning of this equation? How to simplify this? Remember, we already learned the formula for dependent event just now. We need to use this formula in order to solve the problem, right? We need to use this formula to solve the problem. Okay. Okay, so let's try to solve the problem one by one. So that means the numerator here is equal to probability of single and under 30 divided by under 30. All right. Are you okay with this part? Okay. Because this question is involved conditional, conditional question. So we need to use this formula. Probability of A intercept B divided by probability B. Okay. So now we have to solve this part. Single and under 30. Single and under 30 it will be the numerator. In this case, is 77. So substitute 77 to the numerator part. Okay, how about the denominator? The denominator is under 30. So in total, how many customers are under 30 years old? 91 of them. Okay, 77 plus 14, you'll get 91. So substitute 91 to here. Simplify, I get 0.846. Okay, next. This one is using this, okay, another example, another table, okay, new table now. And the variables involved will be salary of the employees and also the age of the employees. Okay, so salary can be divided into 3 categories. Below than 25,000, okay? The second category is 25,000 to 45,000. The third category is more than 35,000, 45,000. And then for the age can be categorized also into 3 categories, less than 30 years old. Second category is 30 to 45 years old, and third category is greater than 45 years old. Okay, so now is we need to make some assumption in order to make our job easy. Okay, so let us use A, event A, to represent employee under 30. Okay, and then B, symbol B, we use to represent employee salary under 25,000. Okay, so first question is, if you choose one employee randomly from this 100, you choose one. What is probability this employee is under 30 years old? 30 years old. So how to solve the problem? That means you have to use number of employees who are under 30 years old divided by total number of employees. Okay. So the numerator is referred to the number of employees who are under 30 years old. How many of them? 30 years old. 35 of them, right? So we substitute 35 to here. 100 is because of NS. So for those who come late, okay, we're still using the same formula that we learned this morning. NA divided by NS. Okay. So we use this formula that we learned this morning, right? In order to get property A, answer is NA divided by NS. So NA means number of employees who are under 30 years, or how many of them? 35 of them, right? NS is referred to total number of employees who involved in this survey, altogether 100 of them. So substitute 100 to here, to the denominator, simplify, you get 0.35. Okay, so bear in mind, probability has no unit. Don't put unit, no dollar sign, no centimeter. There's no unit. The result for probability is between 0 to 1. So don't put dollar sign. Okay, next example. Okay, we use the same table again, all right? But now we want to identify what is probability the employee that we choose have the salary under 25,000. If you choose one employee, what is the probability that this employee has salary below than 25,000? That is the meaning. Okay, so that means you're asked to calculate PB, probability B. So in order to answer this question, we use NB divided by NS. Okay. So NB is referred to number of employees who have salary below than 25,000. Okay, below than 25,000 is this category, right? So we need to sum up this column. How many of them? 43 of them. So 43 should be used as the numerator. Denominator is referred to total number of employees in the survey, altogether 100. So you'll get 0.43. Okay, next example. Okay, same data again, but now the question is asking, if you choose one employee, what is the probability that the employee is under 30 years old and his salary is under 25,000? N. So that means we have to put N here. Okay, A and B happen. A and B. So in order to solve the problem, we can use formula if you want. The formula is N A intersect divided by number of sample. So what is the element? The number of employees who fulfill these two characteristics, under 30 and have salary below than 25,000. 32 of them, right? So we substitute 32 to the numerator. NS is equal to the total of employees. So simplify is equal to 0.32. Quite straightforward. I think my laptop now is also under battery now. Our battery. So far so good. Okay, next example. I think I'll just try to finish this example as soon as possible. Okay, next example will be this one. Okay, we use the same data again. Okay, but the question now is, if you choose one employee randomly, what is the probability that the employee
will have the age, okay, below than 30, or salary is under 25,000. Or is very important here. Or what is the meaning of all here? All means union. This morning we already learned union, right? All means union. In statistics, all means union. Okay, this one means union. Okay, so you can use the symbol of this. Remember, P or means union. This one. So I can simply use the U symbol to represent all. Okay. So how is the formula that we learned this morning? If you want to solve the problem that involve union, then we need to use this formula that we learned. Okay, probability A plus probability B minus probability A intersect B. Yeah, all means union in statistics. Okay, so this whole thing actually is asking for this A plus B minus A intersect B. Okay, union. Huh? Okay, so there are two ways to get the answer. There are two ways to get the answer, right? Remember, just now in part A, we have calculated probability A. Remember, if you go back to A just now, we have calculated the probability of A value, right? How about probability B? We also already have the answer from part B just now. It's equal to 43 over 100. How about probability A intersect B? Also already have the answer in part C, which is 32 over 100. So we can substitute these three numbers into the formula of union, right? So this one you can get from part A. This value can get from part B. This one from part C. Simplify is equal to 46 over 100, right? Which is equal to 0.46. Another way is, okay, you can, in order to get the answer directly, you can try to identify any areas that involve A and B. Okay? A will be H below than 35. So this area, right? This area, plus below than B. Okay, below B, that will be below than 25,000 salary. Yeah, that will be this area. But don't forget, this part is, I think I already run the battery. Hopefully can use this one to, I'm not sure whether I can do like that or not. Okay, I got to get the wire first. Okay, hopefully the online student can hear me. Okay, testing. Okay, James can hear me. Thanks. Thanks for your response. Yeah. Sorry, because I think this morning the audio system got some problem. I think I need to off. Can you hear me now? Can I think can already. Okay, all right. So let me share the screen now. One more time. Okay, we go back to example 10 again. This is part D. Part D, okay? Okay, then I'll move on to next section, E. I think all are here already, right? Okay, let's go to E. E, we use the same example data, right? But now the question is, you are going to choose one employee. What is probability that this employee have salary under 25,000, okay, and is also under 30 years old? No, this one is given, and given B happen, so that means given. I need to rephrase this sentence. Under 30, given the salary. Okay, I need to rephrase this sentence. Okay. So for question A is, if you choose one employee, what is the probability that this employee is under 30, okay, given that the salary is under 25,000. That is the meaning of the question. So how to translate this sentence into a mathematical equation? So that means you're asked to calculate probability A given that B already happened. Okay, A given B. Okay, so if you see the equation involve given or conditional, then you need to apply the dependent event formula, right? You remember, we have to use probability A intersect B divided by probability B. Okay, because A and B are dependent events. Okay, so this formula, you have to apply the formula that we learned just now from this slide. Okay, from this one, slide number 18. Okay, when you see the question involve conditional, then immediately you apply this formula. Okay, let me go back again to the sample. Okay, so you write down the formula first step. Then the next step is we need to substitute the relevant value into each part. Okay, this part, A intersect B. We already have the answer just now. In part C, we already have the answer. A intersect B, where is the value of A intersect B? A intersect B is this one, right? 32. So we substitute 32 to here. Okay, divided by probability B. Probability B is equal to 43 over 100. Okay. Probability B is equal to 43 over 100. And then probability A intersect B is for 32 over 100. Okay. This one is 32 over 100. And then the denominator is probability B, which is 43 over 100. So 100 can be compensated, right, for both layers, can be simplified. So get 32 over 43. Simplified answer is equal to what value? Is it equal to 0.744? Okay, all right, next example. Okay, using the same data, okay, but now is, what is probability the employee is under 30, okay, given that the salary is under okay, let me check again. This sentence is also not correct. Okay, what we want is we want the salary. This question should be an employee with salary under 25,000, given that, okay, the employee is under 30 years old. Okay, so this is the question we want, right? So how to translate this sentence? That means this question is asking for property B given that A already happened. Given that A already happened. So A we put at the back. So how to apply, how to change or simplify this expression here? Okay, you can use the formula that we learned this morning. Okay, so since A is at the back, right? So we put A as the denominator. Okay, then the numerator should be A intersect B or B intersect A, same meaning. This one you can use A intersect B or B intersect A, same. Okay, same meaning. Okay, so you need to solve this part. A intersect B, what is the value we get? We get 32 over 100. Okay, 32 over 100. So substitute to here. Denominator is property A. Property A is under 30 years old, right? So we have to get the total number of employees who are below than 30 years old. Altogether, 35 of them. Okay, so it's 35 over 100. So simplify, you can and substitute to here. Okay, okay, the answer is equal to 0.914. Okay, next example, more challenging now. Okay, using the same example table, but the question now is different. This question is, if you select one employee, what is the probability that the salary is at least 25,000? That means it's more than 25, or at least 25,000. Given that the age is at least 30. So given that the age is at least 30, so that means this one should be the denominator. Okay, this part should be the denominator. So if you simplify, this equation means you are asked to calculate the probability the employee is at least have the salary below than at least 25,000 salary. Given that, okay, his age is at least 30 years old. That is the meaning. Okay, so now we need to change this equation by using the dependent event formula that we learned this morning. So that means this one means this one is probability salary at least 25,000. Intersect the age at least 30, right? As a numerator. The denominator is probability of age of the employee at least 30 years old. Okay, so now the numerator part, this part, we need to identify how many elements fulfill this part. Salary at least 25,000. Salary at least 25,000, that will be these two categories, right? These two categories. And age must be at least 30, so it must be more than 30 years old, or equal to 30 years old. So should be these two rows, these two columns and these two rows. So should be these four. Only these four numbers should be included as the numerator. This number, 18 plus 21 plus 10 plus 5, fulfill the characteristics of this numerator. Okay, so simplify, I get 54 will be the numerator. How about the denominator? Denominator is the age at least 30. Age at least 30. Okay, we have to check. Age at least 30, so it should be 49 plus 16. So these two numbers should be summed up as the denominator. Okay, I'll get 65. Simplify is equal to 0.831. So far so good. Okay, so these are the steps involved if you want to solve the problem for dependent events question by using the joint probability table. Okay, then we can use this method. Okay, we still have some time, All right, so I'll go for one more example before we call it example 11. All right, the tree diagram we can learn during the tutorial. Okay, this example, okay, let's analyze the question first. Example 11. There are 6 blue balls and 5 red balls in a box. It seems to be quite similar to the question that we learned this morning. But you may find that the way to choose the balls are different now. Okay, 2 balls are randomly taken one by one without replacement. Without replacement is the keyword. Without replacement. What's the meaning? That means you choose the first ball. Okay, after choosing the first ball, you are not going to return the ball inside the box. Then you choose the second ball. Jot down the color. Then it's not going to return the ball inside the box. That's the meaning of without replacement. If without replacement, that means like the first event and the second event of choosing the balls are two dependent event question. Okay, two dependent events. if without replacement. Okay, so be careful with this type of question. So let's try the first example. A, what is the probability of choosing one blue ball and one red ball? Okay, one blue ball and one red ball. Okay, so it can be the first ball is blue, second ball is red. Or the second combination can be the first ball is red, second ball is blue, right? So let's try to solve this one. What is the probability? The first ball chosen is blue color. Answer is 6/11. Right? 6/11. If you choose the first ball is blue. Okay, we take out the blue ball. All right, first ball is blue. We take out, right? And we are not going to replace the ball. That is the meaning. I'm not going to replace the first ball. Okay, now we choose second ball. Okay, second ball. What is the probability? We'll get red color. Answer is 5/10. You may ask, hey, how come it's 10 now? Because the first ball chosen is not going to return inside the box. So when we choose the second ball, the total of balls inside the box is only 10, not 11 anymore. Right? Remember here? Yeah, it's 10 only for the second ball. Why? Because the first ball chosen is not replacing inside the box. So when we choose the second ball, in total only 10 balls inside the box. That's why the denominator for the second event is only 10. Yeah. All right. How about 5? 5 is because in total there are 5 red balls inside the box. Okay. So this part okay for you? This part. Any question? I stop for a while. Are you okay with this part? 5/10. Do you know how to get 5/10? For the second ball is red color. Okay. Okay. All right. Because this question does not specify the first ball must be blue or the second ball must be red. So it can be another combination. It can be the first ball chosen is red color and the second ball is blue. Okay. So what is the probability of choosing the first ball is red color? Answer is 5/11. Right? 5/11. Okay, first ball. We take out. Right? 5/11. Okay, now we choose the second ball. What is the probability? The second ball is blue color. Answer is 6/10 only. Right? Remember, there are only 10 balls. What happened to another ball? The first ball that we chosen is not replacing inside the box. So when we choose the second ball, there are only 10 balls inside the box. Okay, with 6 balls are blue color. Okay, then we simplify this expression. Right? Simplify one by one. This one simplify, you'll get 30/110. This one also 31/110. Simplify, you'll get 6/11. Quite tricky, this one. This part is tricky. Yeah. Okay. All right, part B. Okay, what is the probability of choosing at least one red ball? Okay, so because this question also does not specify the first ball must be blue, second ball must be red. So we need to consider the possible outcomes. It can be the first ball is blue, second ball is red, or the first ball is red, second ball is blue, or both balls are red color. Okay, it can be this combination. Okay, so let us try to solve the value for each combination. Okay, for the first combination, what is the probability? The first ball is blue color. Answer is 6/11. Right? Okay, then what is the probability? The second ball is red color. Answer is 5/10. Right? 10 is because the first ball chosen is not replacing inside the second box when choosing the second ball. Right? When choosing the second ball, the first ball is not replacing inside. So that means the denominator for the second ball is only 10. Okay. So this is for the first outcome. Okay, second outcome. Second outcome, it can be the first ball is red, second ball is blue. Okay. Third outcome can be both are red. Because both are red, that means we only count one time. Okay. So if first ball is red, what is the probability? Answer is 5/11. Okay. Then we choose the second ball. Second ball, we only have four red balls left. In total, only 10 balls inside the box. So the second, the probability of choosing the second ball is red color for this question is 4/10 only. Okay. So simplify, you'll get 8/11. Okay, part C. This one is very certain. Part C is what is the probability of choosing both of the balls are red color? This one very certain. Only one combination. That means the first ball must be red. Second ball also red. Okay, there's a meaning. Okay, so now we have 11 balls. Okay, what is the probability of choosing first ball is red color? Answer is 5/11. Okay, 5 is because there are 5 red balls. 11 is because in total there are 11 balls inside the box. All right. Okay, first ball we need to put outside without replacement. Okay, so first ball we need to put outside. Okay, now we choose second ball. What is the property? The second ball is red color again. Answer is 4/10. 4 is because there are 4 red balls. 10 is because in total there are 10 balls remaining inside the box. Okay, so you get 4/10. So simplify, answer is 2/11. I stop for a while. Any question? So that depends on the question. For this question is dependent events because choosing the first ball, okay, the result is going to affect the second ball result. So that means even A and B are dependent. Okay, last example will be, what is the property of choosing? Both balls are similar, have the similar color. So in this question, there will be 2 possible outcomes. It can be both balls are blue colors or both balls are red color. Yeah? So answer will be this if you simplify. Okay. So in short today, okay, I have done a summary for you. What we have gone through today. Okay, so this is a summary for the formula that we have learned so far. So today we already learned the basic formula to identify the property of one event. So if you want to calculate property of event A, then you can use formula of NA divided by NS. Right? So bear in mind your property for event A or one event must be between 0 to 1. Can be equal to 0, can be equal to 1, but cannot be negative number, cannot more than 1. If your answer is outside the range, that means something wrong. Better check your answer again. Okay. And what else that we need to know? Property A plus property non-A is always equal to 1. Okay. So if you want to calculate property non-A, you can just transpose the formula, right? If you want to get property non-A, then what you can do is you can move property A, the right-hand side becomes minus. So it's 1 minus property A, you'll get property non-A value. So play around with the formula, okay? And besides that, you also need to know the union rule. Union means this one. Union is a U symbol. In statistics, union also means or union, okay? Or we use plus. Union is also using plus symbol. So what is the formula to calculate property A union B? Our formula is using A, property A plus property B minus property A intersect B. Okay, so this formula is applicable whether the A and B are mutually exclusive, dependent, independent. We use this formula to apply for all of the events. Okay, if you want to calculate the union value, A union B value, we use this formula. So this formula is applicable for the mutually exclusive, dependent events and independent events question. Okay, the only difference is only this one, this part. The A intersect B value is depends on the relationship between A and B. Okay, if the A and B are mutually exclusive, that means A intersect B is equal to 0. If A and B are dependent, no, independent first, independent events, then A intersect B is equal to probability A multiply probability B. Okay, if A and B are dependent, and then we can simply use this formula, transpose this formula for dependent event. So it's equal to A intersect B is equal to property A given B multiplied with property B. Okay, so the difference is only here. It's only the A intersect B. A union B, we use this formula to apply for mutually exclusive, independent, and dependent. Okay, then the next event will be mutually exclusive. That means A and B cannot happen at the same time. Okay, so if you're asked to calculate property A intersect B for the mutually exclusive question, answer guarantee is equal to 0. Okay, like swimming and attempt online test cannot happen at the same time. So A and B probability is equal to 0. Independent event, throwing 2 coins, throwing 2 dice, throwing 1 coin and 1 dice. Okay, because these 2 events cannot happen at the affect each other's result. Okay, so we call this as independent events. So for independent events, you use this formula. Okay, probability A intercept B is equal to probability A multiplied probability B. And besides that, because A is not going to affect B, B also not going to affect A, yeah, for independent event. So bear in mind, if that's the case, then A given B is equal to probability A, and B given A is equal to probability B. Okay. Lastly, okay, dependent event. If the question involving dependent event, that means A depends on B, B depends on A. Then you have to use this formula to identify, to solve the problem for conditional question. So probability A given B is equal to this, right? B given A is equal to this number. So if you're asked to calculate A intercept B, A intercept B, if A and B are dependent event question, then we can transpose the formula. Okay. So today we also try to learn how to use the joint probability table to solve the problem for dependent event question. So during the tutorial, I'm going to teach you also how to use the tree diagram to solve the independent event or the dependent events question during the tutorial. Okay, so our test, online test 1 will be conducted during the mid-semester break, and we'll cover until this chapter. Okay, the details I'm going to discuss during the tutorial this week. Okay. Yeah, I think I need to call a day because I think another lecture is coming soon. I just call a day. Okay, any other questions from the online student? Online student, any question? Before we call a day, I just stop for a while. All right. Thank you. Okay, all right. No question. Just mean okay. Thanks for your response. And I'll just stop to do recording, and I'll see you during the tutorial this week. Oh yeah, and then coming week we have this Wesak Day, right? Monday is Wesak Day. Coming week, So we have a replacement class on Tuesday afternoon. Coming week. Do you have any class Tuesday afternoon, 2 to 4?
No, Tuesday we're free.
Tuesday free. Okay, I'm going to make announcement later on through the Canvas. So the coming class, coming week lecture will be conducted on Tuesday 2 to 4. Okay, we are going to cover the business statistics part 1. Okay, so if no other question, then we'll just call it there, and then thank you for coming. All right, I'll stop to do the recording now.
Thank you, sir. Have a nice day.
Okay.